Hello there and welcome. I'm Ryan Chan, CEO and founder of UpKeep. In today's video, we're going to unravel the fascinating world of programmable logic controllers, better known as PLCs, and their vital role in industrial organizations. We'll delve into their history, their types, their key components, and how they form an integral part of a predictive maintenance system. You'll also learn some best practices for maintaining your PLC systems and the benefits they bring to various industries. So if you're part of a maintenance or operations team looking to enhance your knowledge on PLCs, you're in the right place. Let's dive in. Let's dive into the fascinating world of Programmable Logic Controllers, or PLCs for short. These handy devices control computer systems in industrial organizations, monitoring inputs to make decisions about outputs. They're often used to keep an eye on motors or machines and form the backbone of a predictive maintenance system, helping businesses catch potential problems before they cause major breakdowns. Let's start with a brief history lesson. The first PLC was built by Dick Morley in his garage in 1969. He didn't even realize what he was creating at the time. His simple relay design with 4 outputs was a hit with automotive companies. By 1973, Michael Greenberg had created a commercially available PLC, which was refined by Modicon for use by General Motors and Landis. Physical relays, wired connections, and timers all benefited from the PLC ladder logic, which allowed increased functionality without a lot of new wiring and hardware. Fast forward to the turn of the century, and we see an advanced version of PLC renamed as a Programmable Automation Controller, or PAC. PACs continued to use PC-based software but added a human-machine interface and asset management. While larger organizations began using PACs, small to medium-sized businesses found the less advanced PLC technology extremely beneficial. Now let's get into the basics of PLCs. Manufacturers use them to monitor selected inputs continuously. These inputs are then processed through a computer system to generate appropriate outputs, making industrial equipment, production lines, and manufacturing processes more efficient. PLCs can adjust or repeat specific operations and collect and share data to help manufacturers make better decisions. There are several types of PLCs and related technologies. For instance, a PAC is typically used for machine control, while PLCs are designed for more complex automation systems. Then there's SCADA, which stands for Supervisory Control and Data Acquisition. It often works as the software partner of a PLC hardware system. When implemented together, SCADA and PLC can form the backbone of a predictive maintenance system. Next, we have a distributed control system, or DCS, which is often made up of multiple PLCs, each assigned to one process or machine. Then there's direct digital control, or DDC, which collects sensor information, assigns it to the proper domain, and manages actuators, often for building automation applications. And finally, there's the human-machine interface, or HMI, which allows an employee to interact directly with a machine. PLCs come in 2 main types, compact and modular. Compact PLCs have a set number of input and output capabilities and are ideal for smaller applications. Modular PLCs, on the other hand, allow easier expansion of an overall system, making them a good choice for larger or growing companies. Despite their differences, all PLCs share some common key components. These include inputs, which are the information gathered by the PLC, and outputs, which are the devices that respond to the interpreted results of the input data. CPUs are the brains of the PLC. Communications equipment and protocols help the data flow throughout the organization. The HMI allows managers and technicians to extract data from the PLC system. Now, let's talk about PLC maintenance. Like any other major system in an industrial setting, it's important to keep your PLC system well maintained. This includes regular tasks such as cleaning dust, changing filters, and tidying the area. Additionally, it involves inspecting connections, replacing modules, and increasing awareness of unusual activity. Backing up data, checking environmental conditions, and calibrating devices are also crucial. Regular visual inspections, checking LED lights, and reviewing error history are essential steps. Inspecting sensors, sourcing electromagnetic interference, and reviewing the proximity of equipment are important for maintaining functionality. Finally, keeping current with recalls, patches, product notices, or upgrades is vital. The frequency of maintenance should be determined on a facility-by-facility basis. Basic tasks like dusting and tidying should be performed daily, while other preventive maintenance tasks will need to be scheduled on either a time or usage basis. A computerized maintenance management system, or CMMS, can help you collect historic data to set the ideal preventive maintenance schedule. There are many benefits to maintaining your PLC system. Not only can you extend the lifespan of your equipment, but you can also boost uptime, save money, and increase productivity. PLCs are used in a wide variety of industries. For example, in the oil and gas industry, well pads often have individual PLCs. In the glass manufacturing industry, PLCs manage material ratios and production processes. In the paper manufacturing industry, PLCs control high-speed machines like newspaper and book printers. And in the HVAC industry, PLCs can be tied together for easier building management. However, as with any system, PLCs carry risks and benefits. Some of the top risks to watch for include input or output device defects, power problems, grounding issues, external interference, temperature problems, and costly downtime. But on the flip side, PLCs offer many advantages. They're easy to integrate, require little space, result in productivity increases, offer project flexibility, make troubleshooting easier, and provide high levels of safety and security. In conclusion, PLCs play a critical role in today's industrial companies. They provide a flexible, reliable, and secure solution for monitoring important equipment and machinery around the clock. Despite some risks, the advantages of PLCs make them an excellent foundation for a predictive maintenance program. And that's it for today's video. Thank you for joining us as we explored the world of programmable logic controllers. We've learned about their history, their types, their key components, and how they form an integral part of a predictive maintenance system. If you found this video helpful, don't forget to subscribe to our channel. For more information and resources to help your maintenance and reliability teams be more successful, visit our website at upkeep.com. Thanks again for watching, and we'll see you in the next video.